John and Kelvin from Tesla Owners of Silicon Valley.
Lars, welcome.
Hey, thanks. Thanks, John. Thanks for having me.
Takeover. This is awesome to be able to have you. Thank you for giving us your Saturday time today, and I know you're incredibly busy. So, but yeah, let's just jump into it.
Okay.
When did you first realize that you didn't want to work on cars, but transforming how they're made? And what motivated you to leave a stable, traditional path, engineering path, to take a risk by joining Tesla in its early and chaotic days?
That's a very detailed question, John.
I try to bring them.
I'm going to try and remember all of it. But yeah, so I joined Tesla in early 2010. And, for those who don't know, before that, I spent about 8-9 years at Honda, which was a very stable engineering job. In Ohio, where I met my wife, who's out here somewhere. I can't see her. And her family. Thank you, Julie, for coming and letting me move to California. But actually what happened in late 2009 was, there was about a year after the economic downturn. All of our projects were getting cut, and pay was cut, hours were cut. And so we had a lot of time to think, and I was younger then. And I got to work on a few cool projects in that time that never saw the light of day. With Honda, we were trying to revamp the entire Acura lineup. And then I saw in those meetings, I saw this 10-year roadmap of engine development. And I was like, well, this is not inspiring. It was very just incremental improvements and efficiency and fuel economy. And then a buddy of mine, Dustin Grace, who is a long time Tesla guy, he was at Proterra, CTO there for a while, and he just started his own company, Estes, super cool batteries. We were at a wedding in St. John of our other friend, Derek. And he's like, hey, I'm working at Tesla now. We got this really cool project. It was the Roadster, and it's super fast, and we're making cars real. And I just want to let you know, I gave all of your numbers to the recruiter. And we're like, okay. And then that was August of 2009. Got a phone call the next week, and started thinking about the vision and where it was going and what it might be, and thought, I always wanted to leave the world a little bit better than I found it, and to marry cars, which I've always loved. And that thought at the same company was an opportunity that was too good to resist. And my wife always wanted to live in California. So at the time it was in LA, and we didn't have kids. So we were like, yeah, let's go check it out for 1 year, see how it goes. 16 years later, I'm still here.
Thank you.
Yeah.
So Lars, you come to Tesla, right? And was there an aha moment, though, where it just dawned on you that this is going to change everything?
Yeah, I came in, and at the time I was, probably employee number 300 something, and Elon was still interviewing everybody, and we were all working in a small building and actually a room in SpaceX. And it was a very different environment from what I was used to, a bunch of great engineers with no process trying to make something cool. And I remember when we built the first alpha prototype there in Deer Creek. That's where our office headquarters was on Deer Creek Road. And we did the first drive at really late at night. There was no doors on, no roof. And I knew it was a great car. I knew it was gonna be a great car. Not a great EV. It was the way that we had built it and the architecture, and from the tires up through the body to the chassis, into the battery and the powertrain, it was so smooth and so quiet. And it was I knew we made a product that people were gonna love, even just because it was great. And I was like, when you make a product people love, they're gonna tell their friends about it, and their friends' friends. And I was like, this is it. This is it. This is gonna be it. And a few years of hell and hard work later, we got there, and it was super awesome. And I think that first drive of the Model S, oh man, I guess that was probably December 2011. That's kind of when I figured it out. It was a couple years in.
So we all know the Model S and X, which are displayed out here, the latest versions, have seen meaningful improvements. You're just counting them off.
I'm counting the number of revisions.
Well, we're going to get into that, but can you talk about what's changed recently and how you approach continuous refinement of these flagship vehicles?
Yeah, it just, a month or so ago, we launched new versions of the S and X. I actually just bought one. Frost blue, great color. And the way we always, when you think about the Model S, it's got this iconic, style that Franz put it in way back when, and that was 2012, and then 2016 refresh, 2020 refresh, now and again. And it's like, when you have a beautiful style, you don't like mess with it. You just like chip away at the rough spots and like polish and push and polish. And I think this last one, we really like honed in on some of the gaps that we had from a few years ago in terms of like interior features, sound, and comfort. I always tell my team we have to make the next car that we make the quietest Tesla that we ever made. And so then we do this leapfrogging thing where like, the new 3 was quieter than the S, which was not great. And then like the Y is quieter than the 3. And so now the S and X are quieter than, those again. And so like we're always just trying to make the next product we make, the best product we can make. And, when you think about what to change, it's always difficult because if people love what you make already. It's like, oh, if I change it, they might not like it. And we spend a lot of time hemming and hawing and making sure the little things we do are things that everybody's gonna love. I think the dynamic lighting in the S is super cool. I think the seats are a little bit improved. The efficiency went up. Even little things like we changed the entire suspension algorithm for adaptive damping into what we call OptiHook, grounded with our physics-based model, and it makes the ride smooth. Something I hated about that car from like 2010 when I remember designing the rear suspension was it always had like a lot of parasitics in the suspension rate, and we changed all the bushings to get rid of that, lower the ride rates on that are lost due to the parasitics, so that we could make the car more flowing and free, and all while maintaining all that super crazy speed that we have and everything. And so it's just like finding those. When you engineer something, you know what you did wrong, or what you didn't do perfectly, or what you could do better. And we just take that moment, that day we release the car, and say, okay, here are the 7 things we wanted to do better, and we do it the next time. And that's what the new S and X have now. Still flagship, still great cars, and probably the best cars in the world that you can buy for the money. The value is just stupid, ridiculous.
Let's talk about the 3 and the Y.
Yeah.
The Model 3 Highland brought some major changes. What was the most challenging or underappreciated improvement from an engineering point of view?
Man. So yeah, Model 3 Highland. What is the Highland name from? I don't know why everyone calls it Highland. Like, we have different codes at Tesla, and like Highland is, I think, the external one. Different. Anyway, yeah. I mean, again, that product, is about a year and a half old now, maybe a little more than that. And it was a great car to begin with. And I think one of the hardest things to do was figure out how to take big steps while keeping, the basis of what it was. And so in that car, we did a lot of, we changed the entire suspension geometry because we wanted to improve the ride comfort and while maintaining the steering response. And when you do that in a factory that exists, and you're like trying to change all the components all at once, and you're trying to keep, the line moving and flip it over on a dime, it's really, really hard. And I don't think people notice, like, you don't see that, right? You don't go up and be like, oh yeah, they moved the upper arm 5 degrees to the rear, and lowered the front lower arm 5 millimeters so that the anti-squat on the rear is like a little bit less now, and that means the car absorbs bumps better, but it does. And we did all that under the scenes and under the hood, and no one appreciates that, right? Like maybe they appreciate the outcome, right? The quality in the ride, but no one sees that work that goes into that. And the people that are here, some of my colleagues I saw earlier that do that work, they never get to show it off. And I think a lot of times we do updates and the skin is similar, and I think that underneath the ground engineering work that's under the skin, behind the interior panels, behind the the A surface, is really where it's at. And I think for the new Model 3, the suspension was really the really big deal, which is hard for me to say because I designed the first suspension, so it's like everyone was just fixing my mess ups, but it was super cool.
So on the refreshed Model 3, a lot of the other cars, even the S and X, now have the front-facing camera. So can owners expect maybe a future update with one? And what are some of the technical or design considerations behind that decision?
In the pandemic, when we had all the shortages, we got rid of all the Ultrasonics and went full on vision and got rid of radar. We did that real quick, and then I think we realized there was a couple blind spots, and one of the most biggest was right in front of the bumper, because the triple cam, or now the dual cam, doesn't see a couple feet in front of the screen. So we decided to add a face cam there, primarily for kind of slow speed driving capability. And the autopilot system doesn't actually use it. It uses inference to know what was in front of the car before it pulls up. But it's super useful for humans, and taking that into account and putting it into the FSD system, it's even better. But I think, it was really just listening to feedback from customers that said, like, I really want to see if it's in front of my car. Okay, we'll put a camera on. And it wasn't that hard of a decision to make. And yeah, I guess the first one we put it on was the Cybertruck, and that was like for off-roading. I think Wes made us do that. He's around here somewhere. And then we just kind of proliferated it. And, I guess I can't say for certain it will come in Model 3 at some point, but like it followed the trend line, it's heading that way.
How about the Model Y, the Juniper? It also brought a lot of new updates. What was the most, from an engineering standpoint, what is the most significant changes that you are most proud of?
That's tough, most proud of. I mean, I think the car just in general is a better car. Like, it's the best-selling car in the world. It's hard to make it better, but I think we did a great job. And like, it's not, it's hard to find some things that are wrong with it at this point, like, in terms of daily use or driving and whatnot. But I think a couple of the like little things that we did in there that people don't notice and maybe don't write about, but were really sort of difficult was, in the second row, we moved the seatbelt from the wheelhouse area to the C-pillar, which is like right on the door. And this is primarily from my experience with my kids. When you fold the seat down or you move the seat forward, you get into the third row, the seatbelt would fall behind the second row seat, and then you can't reach it, can't get it. And so we moved it to the C-pillar so it stays like nice and neatly tucked away there so you can always grab it. And that sounds super easy. Just move the seatbelt. But the seatbelt takes so much load and so much crash, and we put it in this little tiny section, like in between the quarter glass and the door, where the seal also had to be. And it was like a lot of painstaking work to like figure out how to carry the load through there without totally changing the body. I remember poking at the team over and over. I'm like, nope, it's got to be there. We got to move it. We got to move it. And finally, the engineers figured out how to do it. And I don't have a new Model Y yet in my family, but when I drive them, I think about it every day, and I'm like, this is going to make people's lives so much better, especially parents. Thanks, Rafa and Elise. You guys did that one. But yeah, like, the amount of work that goes into just that little bit of movement that can make someone's life better is super cool. And then, really the whole second row seat is a big win for us. I mean, we added power recline, we improved the comfort of it, the fold flats faster, and you get the seatbelt in the right spot, and then you get the rear entertainment screen. So I could think making that more of a family car and all the engineering work that went into that second row cabin space, it's like, Tesla's always been fun to drive, super awesome to be in the passenger seat. Now you got an SUV, it's super awesome to be in the second row seat too. So that was a big win.
Yeah, I love the new Model Y. It's just such an insane difference from even the first one.
Yeah.
But as Tesla transitions, from factories to produce the Model Y, you guys obviously had the shutdown for across the world, and it's a brand new vehicle pretty much. What are some of the underappreciated things or big challenges that you guys face just navigating all of that, doing it simultaneously across the world?
I mean, I think in order to like preserve my job, I would tell Elon periodically as we were about to do this, I was like, Elon, I think this is the largest changeover of vehicles that have ever occurred in the world at any one time. And like I would say it every couple weeks just so you would remember it, because I was like pretty certain we were going to mess this up. 4 factories. We did it in like a total of like 3 weeks, like across first China, then Berlin, Austin, and Fremont went all at the same time. China was a couple weeks early just because of the shutdowns. And I think the hardest thing to do is like the underappreciation actually from our supply chain partners. It's one thing to do it in our factory. In our factory, we make a lot of the components to make our own vehicles, right? But there's like hundreds of suppliers. And in many cases, we have suppliers like in multiple locations. Like we have, I always say this when people ask, but like Tesla makes the most American-made cars in the world. We make the most Chinese-made cars in the world. And we make the most, German-made cars in the world because they all come locally sourced from those regions. And that means we have multiple suppliers, and we have like, you take even something simple like a headliner, and you got to blow up the airbags and make sure that they work in all 3 suppliers in all 3 regions all at the same time, and shit goes wrong. And so my team was all over the globe, and we were just like meeting constantly at various hours of the night or in the morning to coordinate what was happening. And then inevitably, some of the unsung things you don't see is like, speaking of the headliner, like it wasn't working in the US, but the China one worked. And so we had to ship the China one to the US. And then we had to validate the North American airbags with the Chinese headliner. And then, we got that going. And then Berlin fell short on production. They didn't have enough parts. And so we had to ship the North American one to Berlin. And, that kind of logistics, like in that planning, it's super hard to do. And it only took us a few weeks to ramp back up to full volume, and I think It's something we were talking earlier, it's something I'm going to remember for the rest of my life. It's like one of the most amazing accomplishments to be a part of. And the thousands of people at Tesla and supply chain and the factories that made it happen, they did the hard work. We were just trying to do our best to like make sure that engineering wasn't the bottleneck, And I would say that is a supply chain success, and they deserve all the credit for that changeover. So Roshan and Karan, great job.
The Cybertruck. There's about 40 modded Cybertrucks.
Yeah, it's the most modded Tesla I think ever. I didn't quite get past the energy building there before.
Yeah,
I gotta check them out.
Well, then you saw mine, the Starship inspired one.
Yeah, I've seen yours before. Awesome. Yeah.
Yeah, Cybertruck. It's so different than anything Tesla has ever done before. What made it especially challenging or rewarding?
Yeah, I think the Cybertruck is a unique project in and of itself. People ask me, like, what's the most rewarding engineering project you ever had a chance to work on? And I think Cybertruck's probably one of them because no one thought it could be real. We showed this car, I guess 5 years ago now, 6 maybe, and it looked fake. It looked, the glass broke.
It worked backstage originally, though.
It did. I have the video. I sent it to Elon that night. I was like, hey, man, here's the video from 5 minutes ago. It worked. And anyway, but no, I think bringing that, bringing dreams to reality is an engineer's job, right? Like someone draws something, it's a dream. And engineers have to take that dream and then break it down to the fundamental physics of it and turn it into the reality. And I think there's so many challenges in this trucks that you guys all drive that are unsung, little things like how do you connect an inner panel to an outer panel made out of stainless steel with no paint and not let the weld burn through. We don't do really any post-processing. It's not like we burn the weld off or scrub it off. We do a little bit of buffing, but that was a lot of processing. That was a lot of in the welding engineers, weeks and weeks and weeks and weeks figuring out how to make that laser weld work. And I think the little challenges like that are what make that car super special. And Kelvin, you said it's very different from all the Teslas we make, but actually it's not. It's got a powertrain that's very similar. It's got a battery under the base. It has seats on pack like the Model Y did a couple of years ago. And the 48 volt system was super hard. The ether loop control system was super hard to integrate. But actually, it's another car. And when you drive it, and you guys drive them, it drives like a Tesla. It doesn't drive like a big truck that when you compare a Ford F-150 to the old Tauruses or whatever they used to make before they stopped making cars. They only make SUVs now. Right? And trucks. They don't make any cars, except the Mustang, I guess. And so I think the hardest part about engineering the Cybertruck was to make it there's too many negatives there. To make it a Tesla. To make it not a Tesla. And because it would have been easy to just say, it's a truck, we can make it different. We can throw out this, the screen and say it doesn't need that because it's not rugged enough. We can throw away the instant throttle response. We can make the brakes feel like crap. But we didn't want to do that. We wanted it to be a Tesla at its core, and it is. And I think that's awesome. And I think that's why so many people like you guys love it because it didn't deviate from what we promised. I know everyone wants a Cybertruck in Europe. Wes is over here. You can ask him about that one.
He's the guy in the backpack here. From an engineering perspective, how does the Cybertruck compare when you mentioned a couple of things, but from a structure, performance, durability, and even manufacturing standpoint?
Yeah, I think there's certainly some benefits to manufacturing. We don't have to paint the panels. That makes it super easy. The safety of the truck is awesome. It's got the lowest probability of injury of any truck that it's ever tested. So, in that way, it compares very favorably from a safety perspective. But from there's a lot of interesting things that kind of fell out once we drew it all and put it together. The triangular shape on the rear gives it a lot of stiffness in the body that most trucks don't have. I think the stiffness is north of 40 kilonewton meters per degree. For reference, that's the same as a McLaren P1. So I think that when you have that kind of ground up engineering, and you put it all together, you're able to make a truck that is super special that doesn't have to be a truck. And I think we didn't treat it that way. We treated it like a car, like a product that we wanted to sell, and then turning it into a truck was the easy part.
All right, I've been dying to ask you this question, Lars. Do you see a need for a smaller or more globally a scalable version to serve broader and more urban or international segments of the pickup market?
We always talked about making a smaller pickup. I think in the future, as more and more Robotaxi comes into the world, we look at those options and we think about, okay, what that kind of service is useful not just for people but also for goods. And so we've definitely been churning in the design studio about what we might do to serve that need for sure.
So thank you first off and the Tesla team for making the Cybercab and even the Semi come. So from a Semi perspective, have you guys hit new engineering and production milestones?
Yeah.
And when might we see the broader rollout beyond like early customers like Pepsi?
Yeah, so Semi's moving along really well. I think we've done a few updates on the factory up in Reno. The thing with the Semi product is like you have to make it super, super reliable. It is the most important thing when you have a tool like that in your fleet, can't go down. And so we spent the last couple of years since we released to Pepsi, and actually more people than Pepsi have it. Watt EV has some, Saya has some. There's a bunch. We have our own. There's a few companies out there they're already taking delivery of their pilot fleets, and we've been churning away, making sure that on the engineering basis, like we're ready to go from a reliability standpoint. Just last week, we built a few betas that are proving out our improvements over the Alpha, the pilot fleet, I guess you call it. And those are going through durability testing right now. Production equipment is going into the factory as we speak. Literally, we're doing it 24/7, and the powder coat lines are going in, the battery and drive unit lines are showing up. And towards the end of this year, we'll be complete with that, and then we'll start building the production version of the Semi in Reno, probably end of this year, early part of next year. And we'll be ramping through second half of 26. So it's like happening. We're going to be in full ramp mode just after we launch Cybercab in Austin. So another couple big product launches there. And I'm super excited about the Semi because it means so much to the mission. When you look at CO2 and the amount of impact that road transport has, that ground transport has, it's half. It's half of what's out there. And like we haven't even made a dent as a community in that. And so I think we made a kick-ass product that's going to really be a no-brainer for people to like shipping companies and fleets that have them to buy, because all they care about is cost per mile, right? And so if you bring down the front end cost of it low enough, and you make sure that the price of the truck is comparable to that of a diesel and it's lower to operate per mile, there is no reason that they won't buy it. And so that's kind of what we've done and we've been working on for the last few years. And those milestones I just mentioned, we're hitting them one by one, and I'm just looking forward to see it on the road. I always get excited when I see one on the road because I'm like, oh, it's gonna be so cool. I was out in Yellowstone last summer, and when we were driving, and I saw one of Pepsi's trucks like coming from Modesto to go out where, and I was like, whoa, man, this is weird. Like just to see that in the middle of nowhere, and 2-3 years from now, they're gonna be everywhere. It's going to be super cool.
Yeah, it was crazy to see the Semi carrying all the Teslas out of the Fremont factory. Like, sometimes when I'm driving by, you'll see them in the parking lot.
Well, that's going to stop eventually because the cars are just going to take themselves.
True.
But anyway, I get your point.
Nice. So, Lars, what is going on with the Roadster?
Oh, man, everyone's favorite question. I did not talk to Elon about it last Sunday night. So, no, Roadster is definitely in development. We did talk about it last Sunday night. It's a super cool product. We are gearing up for super cool demo. It's going to be mind-blowing, I think, as Elon says. We spent a lot of time last few years like rethinking what we did and why we did it and what would make it an awesome and exciting, say like last best driver's car, I guess. Given where our Tesla is going with autonomy and stuff, we know that it's, I don't want to say it's a swan song, but like if we're going to make this transition to autonomy, like, driving cars turn into like a luxury. And so the Roadster's got to be the best, right? And we've been making it better and better and better. And now, as you know, it's even a little bit more than a car. We showed Elon some cool demos last week of the tech we've been working on, and he got a little excited. So.
Yeah, it says it's going to be unlike anything, the demo of that. So the SpaceX package, is that proving to be the biggest engineering hurdle in finalizing the Roadster, or are there other factors slowing the program down?
That's definitely hard.
Fly a little?
We were with, I was meeting with the SpaceX team last Thursday just for a minute. It's a challenge. It's not, like if you think about just like fuel to weight ratio of a rocket, right? Like it's like 90 to 1, 90%, fuel to weight, and maybe 95 is really great. But when you have a car, it has to do all the car things. There's a little bit more mass there, and you get a separate propulsion system to do the car things. Your fuel to weight doesn't exactly work out to be these high 90s, and that's been making it a bit challenging. But we found some really cool ways to get the mass where it needs to be, to get it to do what it needs to do, and then it's super fun working with those guys. Like, I think we have a lot of respect for each other as engineers. Yeah.
So Lars, we've talked about the intense climate environment, the anti-Tesla environment, the last few months, and we've been doing our part, in dropping donuts at
Appreciate
stores
that.
and all that. Yeah, of course. How have you, Tesla, your engineering teams, kind of weathered the storm, and how has this period impacted the Tesla brand, and for better or for worse?
It was an interesting question, Kelvin. I do appreciate you guys. I know I reached out a few times. It was like, hey, let's meet hate with love. And I know a lot of you guys went out and brought donuts and did that, and I really appreciate that. Having such a strong community that you can fall back on when you have tough times is super humbling, and it really it's awesome to know that we have all of you guys here to do that for us and make us feel like we're actually doing the right things. So thank you, everyone, for that. Engineering, it's really easy to put your head down and just grind. And I think a lot of us have done that. We really focused. We had a really tough, first half of the year with launching the Model Y around the globe. And so when you do that, you can kind of put your head aside for a minute and realize the products you're making and what their value is to the world and to the community. And so I think for the most part, that's how my team handled it and kind of pushed through it. And it's nice to see some positive news again. The diner opening this week was awesome.
So awesome. I experienced it on Monday.
I see a lot of people with diner shirts on, and we were out there last Sunday. That was after the studio. We went to the diner, and it was cool environment to see everyone and the positivity around it. And I'm sure a lot of you all went there on the way up. Yeah, it's nice to see it coming back around.
Jumping into the Robotaxi, which we know is in the Model Y in Austin, and
here now.
Yeah, really?
Yeah,
No.
this is week. I mean, he's got a safety driver in it, but
Okay.
yeah.
Hey, fair enough. But yeah, the Robotaxi is expected to debut on a purpose-built platform. What are the key design and engineering challenges in building a vehicle meant to operate without a driver from day one?
Yeah, there's no steering wheel, so it's hard to test.
I can't imagine.
Yeah, so it was kind of a fun thing because normally when you develop a car, it's like the first thing you want to do is make the wheels spin. So you have it on a lift, and you're like, okay, the wheels spin. And you're like, okay, now I got to turn the wheels. And like normally that's easy when it's mechanical connection. Cybertruck was a bit harder because there was nothing connecting it, so we had to do a bunch of code. In this car, we were like, how are we going to drive it? I was like, we have to like test it, crash it, do stability control reviews, do firmware, development, and so we're like, oh shoot. So like, if you see the RC fleet running around with steering wheels, that's because we had to figure out how to test it. They're not for sale or whatever. That's just a test feature only. And actually, I think it's straight out of the Cybertruck wheel, so it's like not even a bespoke thing. But that definitely made it hard in engineering because you got to make it, to design it to be no steering wheels, no mirrors, no brake pedals, no accelerators, and then also figure out how to test it. So it's definitely a challenge. The other big challenge I'll say is like efficiency. The watt hour per mile on that thing is super bespoke just for getting the most out of every dollar per mile. And I think that having this balance of like, okay, but now that a human isn't driving it, I can take away some of the limits that we put into cars because humans overshoot because their steering inputs and their braking inputs are aggressive. And then you think, oh, but wait, autopilot's driving it. It might want some of that margin. And so this balance between how much do we pull back in order to gain efficiency, like on things like the tires, while maintaining a super safe, super reliable vehicle for autopilot to drive, because it's also a driver. The FSD system is basically a driver. Was a bit complicated in our first go. And so like I think that it's going to be a great product and it'll be super good, but I think we can go further. I think we can do more. I think we can make it more efficient. I think we can make it ride better. And then I think because we had to just take a baby step, little cautious step into this first effort of no human in the loop.
So Lars, during our prep call, you were talking about your title and it's head of vehicle engineering.
Yeah.
But that title is actually not quite accurate because you actually are responsible for Optimus.
Well, yeah, I mean, this is a little bit weird. Elon's responsible for Optimus. Let's be clear about that. My team, does manufacturing for Optimus and testing for Optimus and actuators for Optimus. And vehicle engineering is definitely a loose title because, I have all the manufacturing engineering, I have all the automation teams. And I think that that's like a super strength at Tesla because we don't have silos of groups that only work on Model Y, or only work on Optimus, or only work on energy, or only work, we all are the same set of engineers. And so I think, I was joking, I'm like, I don't even know what vehicle, like maybe at some point I was only in charge of vehicle engineering, but I don't know when that ship sailed a long time ago. And it's been awesome and inspiring to like be a leader for all these engineers that and technicians and people that work with me, and like I get to represent them in situations like this. And I think it's undersold how powerful that group of engineers is, compared to what the rest of the industry might be able to muster. And I was talking to Sandy backstage, and he's just shooting the shit about various projects, and like when you realize how broad you can go because of what you're working on, it's like, wow, yeah, that's super powerful. And I don't know, head of something.
You need to come up with a new title,
Yeah.
like Elon Tech Knocking. What's been the biggest difference working on, I mean, obviously you guys build the machine that builds the machine, but when you think of like vehicle engineering to now humanoid robots, what is some of either the learnings from, making a car versus a robot, like a humanoid robot?
Yeah, I mean, I would say one of the most interesting things about like trying to build Optimus and manufacture it is like the precision. The human body is amazing. I don't know. Once you start designing a humanoid robot, you sit in a meeting, you just hold your hand up and you're like, how do I do that? And you kind of move your joints around and try and figure out how to emulate that mechanically. It's really hard. The human body has some amazing things. The team I know just went and visited a hand surgeon to figure out how the human hand worked a little better, and it's crazy to watch and see what the tendons do and how the muscles pull them. And when I was growing up, I always thought working on cars was a bit like being a surgeon, because you got the hoses and cold fluid comes into the engine on one side and hot goes out the other. It's kind of like a heart, and it is not at all the same. It's very difficult to get the precision you need and the response and the tactility. And I think, as Elon was talking about the other day on earnings call, Gen 3, the robots can be quite a step forward in those kind of things.
Do you pay close attention to how other EV makers, particularly in China, are innovating with different form factors and even features like dancing, ability to dance? And
Yeah. I mean, China is a powerhouse of building, if nothing else, right? They can manufacture everything and anything under the sun faster than anyone else in the world, and that's a superpower that they have. But we're as with cars, we're always looking at what other people are doing. But I think even though we're paying attention, like we're grounding ourselves in what do we think is the right solution. And when you look at some of the robots that have followed the Optimus revolution, I guess, or even the humanoid revolution, I should say, I think they're less generalized than what we're doing, and that's going to spawn a problem for them down the road somewhere. Like as with FSD, we've gone with a generalized solution and trying to make the robot live in the human world that we've spent, I don't know, 20,000 years developing, right? So yeah, we pay attention, but we don't let it necessarily change the thought process we have.
Solid state batteries are often called the future. Is Tesla actively researching them, or do you see better near-term gains from refining current chemistries like 4680s or silicon-based?
Yeah, I mean, battery tech is definitely at the forefront of a lot of things we do at Tesla. It powers every product that we make. It's one of our core, responsibilities, I guess, to the world, is to continue to push that forward. And I think, if you look year over year, battery improvements have always been incremental. About 3% energy density improvement year over year, or something like that, and maybe similar in fast charge. And you can go back decades to figure out when the first lithium-ion battery happened and follow that linear trend. And I think we'll continue on that trend, and we continue to refine it. Every couple years or so, we change over our entire battery cell factories with our vendors. We just in China with CATL launched a new cell a couple months ago with the new product with the Juniper, and also with LG we improved that, and we did that through incremental improvements, through electrolyte changes, through cathode changes, through anode changes, through packing densities and manufacturing process changes. And I think that's going to keep going for a long time, and we're going to find a lot of more improvements in the batteries that we make in our vehicles, and whether they're coming from our house, our production factories of 4680 or our vendors, Pana, LG, CATL, whoever. That's going to continue to happen. That doesn't mean we don't also look at trends like solid-state batteries and supercaps and other things that might provide other alternatives of energy. But lithium-ion and lithium iron phosphate, but those cells have really proven their worth in terms of like energy density and capability, and I really think we're only in the beginning of that. I still think there's a lot of gains to be made in microchemistry and in those form factors.
So you've worked with Elon for over a decade now. How would you describe your working relationship with him, and how do you approach collaboration when he's pushing for something that seems nearly impossible?
Yeah, I guess I have. I think working with Elon's fun. To have a boss that understands you, like at physics level, at engineering level, super cool. I didn't, I imagine a lot of CEOs aren't like that. I don't know too many, but it really drives the culture in our company and in our conversations that he's always grounded in, like, is this possible? How do we do it? What can we do? And I don't shy away from tough discussions with him if we have to have them. What I know is you don't go talk to Elon without knowing what you're talking about, because he's going to root that out real quick. And so I always try and stay grounded in the conversations with Elon, and I found a way to communicate with him over the years that we have mutual respect for each other, and like he knows when to ask me to push harder or to make sure that we're innovating more, but at the same time, like, I think we've earned a level of trust with each other that he knows my team and I are just going to get shit done. So yeah, like he's larger than life for sure. But when he's in the meeting room with us, I wish people could just see it. It's just like a bunch of engineers talking about shop, It's super fun.
Let's talk about Franz. I mean, you guys have been on Jay Leno together. How do the two of you guys work together, and do you find it unusual in the automotive industry for engineering to embrace such bold, unconventional designs the way Tesla does?
Extremely. Franz and I are good friends. I'm like happy to call him my friend. I think I first met him, I guess 16 years ago when I started at Tesla, and he's been there just a little bit longer than me. And I was looking at the early Model S clays with him, and I stood there and I looked and I was like, tires are too small. And he looked at me and he's like, yeah, they are. I think that kind of spawned our relationship because I like cars and I can appreciate what he does. Like, it's beautiful design is like what sells cars. Engineering just powers the the wheel horse behind it. And I think our relationship's always been like that. Like, he knows I appreciate what he does, and he's never afraid to ask us to do something crazy. And we're like always telling the engineers, you don't get to say no. You can say yes, and it's gonna take this, and this. But like, there's nothing that anyone can dream of that we can't figure out how to do. And so that relationship is very different, I think, at Tesla, and especially like you can see it in the way Franz and I work together, and it permeates, through the teams. Like, we all try to make each other's ideas happen. There's no animosity of like design or engineering or whatever. It's just one team, and we're trying to make really cool things happen. And sometimes we get it right, and sometimes we got to go back and do it again. But yeah, I'm super grateful to have that. Him as my partner in this journey.
One thing I know you like to talk about is the machine that builds the machine.
Yeah.
Right? It's something that most people don't understand.
So fun.
Yeah. So let's talk about it. What is about it that allows Tesla to build much of this machinery in-house that builds your machines? Right? What's the advantage of that? And how does it help you move faster or innovate faster?
Yeah, I mean, I think, we just talked about with working with Franz and not being able to say no. Well, one of the superpowers we have at Tesla is like our automation groups and our manufacturing engineering departments. They're just like, I think about the 6,000 people that work for me, about 2,000 of them are in automation and machine building. About 1,800 are in manufacturing engineering, and about 1,800 are in design engineering. And then you got support and technicians and things like that. So it's like really a third. And when I think about that, it's like, why is that so important? Well, when you invent something new and no one's ever made it before, it's much easier to have the team that's going to build the machine on your team, so you don't have to work through these layers of like even stupid things like I need a quote from a vendor to supply the machine, and like that takes 2 weeks, and then they got to check with their suppliers, and that takes another 2 weeks, and you end up with this stack of like timelines that like really 2/3 of it is just back and forth between different companies and different levels. And in the end, you're translating that same goal of whatever it is you're trying to make through that same bureaucracy of tiers of companies. And so at Tesla, it's like, hey, I want to make this thing. I don't know how to. And you're like, okay, let me call the guy or the girl who is like most closely made a machine that's built this before. You call them into the room, and they come in the room, and they're like, well, I could do it making, like the panels on, well, not that one, but on the Cybercabs. When we were doing that idea of like, how do we make these panels that are paint, look like paint, but aren't paint, and like are super easy to replace and durable. And so we brought a design engineer, and we had Franz's color team in there, and then we had the plastics team in there that builds the plastics machines. And then we're like, you know what though? We need to change the materials. So we brought the materials teams in, and Amir's here somewhere. He's a big part of that. And like, you can't do that in many companies. It just doesn't exist to the level of expertise we have. And so that might be a 2-hour meeting, and you come out with an actual idea of how to make something real. And then you go do it. And so that speed is just like all throughout that process. That just takes away months and months of iteration. And I like building Optimus and building, this is the same thing. It's like we had to invent new automation equipment with a level of precision that most people don't use, maybe except in like the chip industry, but we're talking about like chips are this small and they don't weigh that much. And we're talking about doing on a 65 kilogram humanoid robot. And we need the same level of precision. So we had to go all the way back to the machine, our machine builders in Germany and say, we're gonna build a new frame. And the precision is gonna be like micron level. And it's gonna move super fast because we got to build, thousands of these things a week. And then we were like, reinvented the machine so that it has more precision and it moves faster. And like, I don't think those companies you were talking about in China are doing that are building robots. And that's what, I get super excited about that. I wish more people got excited about it. Like, it's the coolest part of working at Tesla.
Tesla's introduced the unboxing manufacturing process. Can you walk us through what that means from an engineering standpoint and how that changes the way vehicles are designed and assembled?
Yeah, I mean, crazy idea. Where's Sandy? I see him. Good idea, right? Good idea? Yeah. When you build these machines and you realize how inefficient they are, like in terms of like getting in and out of it, like, a car is built around a human. So like when you're assembling it, you have this big void of space that is inside the car where humans sit in the end. That means you have to carry that like through the entire factory. And like when you watch the body go down a body line and it's like mostly air, you're like, what am I doing? Like, why am I, this capacity of this building is based on the air for the humans. And so we had this idea, like, which starts, with smaller products. You look at the computer industry, and they build all these like small subassemblies, and they put them into layers in the big PCBA, and then the PCBA goes into a case, and it's like all of these lines come in through these arteries, and they filled a really small main line. And we said, why can't we do that with cars? A lot of people said, well, the structural load paths go through the A-pillar, like they won't be able to support crash. And then other people said, you won't be able to get the precision, and you need a slip plane here. And I was like, no, those aren't reasons. Those are like challenges. And we, isolate the challenges, whether it's structural loading through bolted joints or it's, assembling a seal plane across like a non-planar surface, and you just break them down individually, and then we go fix that problem or find a solution to this challenge, and then you put it all together, and we got the product, and we think it'll work. We're testing, and first crash tests were last week, and it was like came out great, and we're like, holy cow, it worked, and like everybody in the room surprised except all the engineers. And so I think like the advantage it will give us is speed, because we can get more people or more robots working on it, any part of the car at the same time. And then instead of having this like super long main line that's like, normally 150, 200 stations, our main line's like 25 stations. And that means we can build cars like at a rate that I think people will be mind blown by, just coming off the line like super, super quick. And so I'm excited to see if we can make that work. So far, so good. A few more months, we'll get it done.
That's it? I think that's it, right? 5 minutes? Okay. All right, let's talk about looking ahead. Mm-hmm. What part of Tesla's future are you most excited about from either a product, technology, or mission standpoint?
It's a personal question. I really think it's a semi. And I never thought I would say that like 5 years ago. Really? Yeah, the semi is so cool. And I think it's on mission, right? Like it is totally the mission. And when it's autonomous, oh my God, like it's just gonna, like we're losing truck drivers all the time. Like people don't want to drive trucks anymore. It's like a really hard job. And like we can make it safer, more efficient, like better for the planet. Yeah, like that's a cool product. I'm really excited that's happening this year. Well, next year.
If you could fast forward 5 years. I mean, it's probably hard to think in that terms of Tesla years.
It's like infinity.
What do you hope Tesla has achieved that would make you proud as an engineer and leader?
I mean, if you had asked me this question 5 years ago, I would have said, man, I hope we're still here.
Fair enough.
Yeah, and so like now I'm gonna say the same thing, man, I hope we're still here. Because, like we take big swings and sometimes that risk, it can come with, a lot of downside. And I think we're in a big swing moment right now with autonomy, with Robotaxis and with Optimus and with Semi. And yeah, man, I hope those all work out, and if they can all work out, and like usually we get it right, and usually we get it done. Just maybe not always on time. And I think it'll
Elon
be great.
time.
Yeah, Elon time.
2 weeks.
It's hard changing the world, man. It's hard, dude. And like sometimes it takes longer than you think it does. Sometimes you think you're right there and then you're not. And I think the next 5 years, we're going to look back and it's going to be like this massive turning point in transportation where before was like somewhat of a burden. And if we can make it less burdensome and thereby like more efficient for the world and hit the mission, then I think that'll be mind blowing. Like I see that future, and like I don't believe it's going to happen sometimes. But what if you want to change the future into something you want, you have to decide what it's going to be and then just go do it. And that's what we do at Tesla. We just go do the future.
Make the future a reality. Well, we just want to say thank you, Lars, for being here today.
Thank you guys. It's super fun.
This is, let's go ahead. But yeah, we just want to say thank you for coming to the takeover, and we would love a photo right in front.
Takeover.
Yeah, not takedown. A quick photo, real quick.
Yeah.
Yeah.
Me in the middle.
Yeah.